So the bad news is that it's hard to do. The good news, no, that's not right. It's not hard to do. You're master students in computer science. Hopefully some of you have seen the graph cuts algorithm. I'm not sure. We may do that later in this class when we do an algorithm thing for segmentation. Graph cuts is a well-known computer science algorithm where you've got two groups of a graph. You have a graph and you want to cut it in such a way that minimizes some value. The cool thing was that Boykov, Wechsler, and Ramanzadeh applied graph cuts to some computer vision problems, and in particular, they applied it to this stereo disparity problem. And when you do that, you get a result that looks like this. And this is pretty good. So on the right here, we have the ground truth. All right, and on the left, you have a picture that looks pretty close to that ground truth. There's still a little bit of issues. I guess green's a bad choice here. Pick red. There's still some issues around here, and of course a little bit with where the occlusion happens. Because remember, we've got occluded pixels near the edges. But in general, compared to that correspondence solution that I was showing you before, it's a much better solution. I also point you to this Middlebury stereo website. There's a whole bunch of ground truth and sort of standards in stereo that's available there. I don't want to give you the impression that stereo is a totally solved problem. There are still some challenges. Textureless areas, it's very hard to know exactly where the match is, and clearly the surface has to have more influence. Occlusions are still a challenge. Violations of the brightness constancy, so things like specularities whose position on the surface move as I move, that violates our stereo. Really large baselines, so I've got a camera way over there and a camera way over there. Well, now I've foreshortened things, right? So here I see the front of the camera, and over here, probably I'm out of the field. Probably Meg can't, I'm totally gone. Well, but all I see over there is the side of the camera. So if I want to do stereo matching, that's a very hard thing to do. And then there's camera calibration errors, right? So remember the camera calibration defines for me the epipolar lines. What if they're wrong by a little? Well, then my epipolar lines are wrong by a little. So how do I deal with that? So these are challenges for ongoing stereo research.